Okay, so the first type of question here is f of x squared, or sorry, f of x equals x squared plus 6x minus 8. So the first thing we want to do here is we want to let f of x equal 0. That's always our first step here. Then we have negative x squared plus 6x minus 8. So I want you to note that the real difference here is that there's a negative in front of the x squared. So the biggest difference here is that there's a negative in front of the x squared. Okay? So when that happens, what you want to do is you want to actually factor out a negative, not just from the x squared, but you want to factor it from the whole polynomial here. You want to go ahead and factor a negative from everything that you have that's together. So your negative x squared becomes positive x squared. Your positive 6x actually becomes a negative 6x. And then your negative 8 becomes a positive 8. Okay. So again, what we're doing is we're factoring out a negative from the negative x squared, which becomes positive x squared. Then positive 6x becomes negative 6x. And then negative 8 becomes positive 8. So again, we're taking a negative from each one of them. The reason that a positive 6x becomes a negative is because a negative times a negative equals a positive. So if you take out a negative, it becomes negative. Okay, so the next thing we want to do is, and again, the reason we do this is we're trying to manipulate it to find the zeros or the roots. We want to divide both sides by -1. Anything that divides into 0 is just 0. So we have 0 equals x squared minus 6x plus 8. The reason we divide by negative is to get rid of the negative from both sides. Now we can go ahead and use our technique from last week. So again, this one is an organizational method. It is not actually necessarily mathematics here. So really you want to think about what two numbers when multiplied equals 8 and what two numbers when added together equals -6. Okay. So you want to think about which two numbers. Here we can just think about it. The different factors you might think about are 1 and 8. No matter what happens, 1 and 8 will never add up to -6. So the next factors are 2 and 4. If you were to add them together, if they're both positive, they equal +6. Multiply equals 8. So we have to think about if they become a -6, then they should both be negative. Okay. This would equal 0 equals x minus 2 times x minus 4. And again, we're going to use the application of the zero product property. If x minus 2 equals 0, then that works. This statement is true. If x minus 4 equals 0, then this statement is also true. So x minus 2 equals 0 or x minus 4 equals 0. So we add 2 to both sides, we add 4 to both sides, and we get x equals 2, we get x equals 4. Let me go ahead and move that up a little bit. Okay. Any questions so far? Any questions? So again, the biggest step here that's different is that if you have a negative in front of your x squared, you're going to divide everything by a negative. You're going to take out a negative from everything you have, and then you're going to divide both sides by a negative. Okay? That's the biggest change here. Okay, does anyone still need this? Okay. Just give it a minute or so. Next problem you can try to go ahead and solve is just x squared minus 1. Okay, so for this one's an example of the product rule that we learned here. So if you were to factor it, you should know that it would just be x plus 1 times x minus 1. If you need the organizational method, you can see here that you're looking for a number that when multiplied equals -1, but when added together equals 0. So anytime you see 0 on the bottom, that means you're going to have the same number, just plus or minus, right? Anytime you have 0 in your organizational method, it's going to be the same number, but alternated, because if you have the same number added together, but alternating signs, it's just going to equal 0. So plus 1, -1, and that's what we have here. Okay. So x plus 1 equals 0, or x minus 1 equals 0. The reason it's or is because we're asking which one would fulfill the mathematical statement, which one would make it true. Again, either or would make it true, but neither has to happen at the same time. Okay, so our answer would be x equals -1 or x equals +1. And try and okay, so we got one last problem here. Just one last problem. And again, if you're feeling comfortable with this, you can already start working on the worksheet. Feel free to. Okay, does anyone need more time on the second one? Anyone need more time on the second one? Okay, last problem here. Actually, yeah. So here, what we're given is it looks really different here, right? Looks pretty different here. So instead of using our organizational method, we're actually going to, and sometimes if it's like this, you can always just switch the sides like this. We're actually going to take out a number, or use the distributive property to take out a number from both of these things. So we want to see what is in common with both the 3x squared and the -12x, right? Think about which number, or what is common in both of them, and then divide both of them by that. Okay. So in this case, what's in common is 3x. And then so we can take out 3x from this. All that's left, if you divide this by 3x, is x. From this, if we divide 3x, becomes -4. Okay. So again, all we're doing is we're dividing both of these by 3x, and we're just saying, well, if I were to take it out from both of them, then we can just have a product of two different values, right? And again, the reason we're doing this, we're just manipulating it, is because now we can solve for the zeros, right? If either one of these things is equal to 0, then we know our products. So we know that 3x is equal to 0, or x minus 4 is equal to 0. So we can now divide both sides by 3, x is equal to 0, or add 4 to both sides, we get x equals 4. So the time when you'll get when x is equal to 0 is in these cases, when you have something times an x by itself. Okay? X by itself. And that's it. Okay. So those are the three different things